All right, this is on page 69 when we are done. There are multiple ways to find missing pieces of triangles and right triangles in particular. Which one you use sometimes depends on what information you have or what you're actually looking for. Sometimes you have more than one option depending on the kind of triangle that you have. And so it's kind of important to have the different tools in your toolbox and you know when to use what and what can make your life easier and when you can't use certain things and so forth. So this is going to be part one of special right triangles. So there are two special right triangles that they're special because we can come up with rules that will allow us in this particular case to do a shortcut as opposed to Pythagorean theorem. With the other one that we'll talk about tomorrow, it's not so much a shortcut. Depending on the information you have, you may not even be able to do Pythagorean theorem with it, depending on what's going on. This one will be on your test. The one that we do tomorrow will not be on this next test. Okay. So the first triangle that we're going to look at is a 45, 45, 90 triangle. So this is the 45, 45, 90 triangle theorem. Okay, 45, 45, 90 triangle theorem. So if this triangle here has an angle measure of 45 degrees here, what's the measure of angle B have to be? 45. Okay. So then what, yes, it's a right triangle. Yes, it's a 45, 45, 90 triangle. But what else could we classify this triangle as? Isosceles. Okay. Because if these two angles are congruent, these two sides have to be congruent. So this is also an isosceles right triangle. So we can, it's not just any right triangle. It's either isosceles right triangle or a 45, 45, 90 triangle. Those mean the same thing. It's just so that you know. You don't necessarily have to be given that that's 45. You can be given that it's isosceles and that it all fits in the same little category. Okay, so before we look at the actual theorem, we're going to come down here and we're going to derive the theorem. We're going to come up with the rule on our own. And first, so this example says, give the value of y in terms of x. Okay, so this statement right here, y in terms of x. Who can tell me what they think that means? Santos? Okay, exactly. Y equals something, something x. Because when you read something like that, you have to know what that's telling, what that says to you, what it's asking you to do. And it also tells you stuff. That pretty much tells me that when I'm done, I'm not going to get y equals 5. Right? I'm going to get y equals something with variables. And so there are times when y'all get variable answers and you're like, I don't know, am I supposed to get a variable? Should I keep going? Well, this flat out tells me, no, you're probably going to get variables. So y in terms of x means y equals something with x. So on the left-hand side, you have to get y all by itself. On the right-hand side, you can have x's in there and some numbers and whatever else, but x is the only variable you could have. If I had a few variables, then I could say something like determine y in terms of x and z. Well, that would mean y equals something with x's and z's in it. Does that make sense to you? So that way you know which one you're getting by itself, what you're actually solving for. So in this triangle here, we're looking for y, right? We're going to get y by itself. And what kind of triangle is it? It's a right triangle. It's an isosceles right triangle. So what could I label this side of the triangle as? X. Because I know that this is 45 also, right? And then these are congruent. Everybody okay with all that? All right, so can I set up a Pythagorean theorem with this? Yes. Okay, what would represent C? Y. Okay, so this is going to give me x squared plus x squared equals y squared. Okay, now as we go through this, make sure that you understand what we are doing right now is not what you have to do every single time. We are deriving the theorem that will allow us to do shortcuts. So you're not going to do Pythagorean theorem like this every single time you work one of these problems. The whole point is to understand where it comes from and why. Okay, so x squared plus x squared gives me what? 2x squared. So 2x squared equals y squared. Right. we're also going to write a couple of extra steps so that you can see the whole process. So I'm going to at this point, I really don't care what y squared is, I want y. But I'm going to rewrite that little equation with the y squared on the left. Okay, so rewrite this as y squared equals 2 times x squared. Now I want to get y by itself. So what can I do at this point? Square root. So I can take the square root of both sides. When I do that on the left, the square root of y squared is just y. On the right-hand side, pay very close attention to this. This is the square root, and these two things are being multiplied. This is a product. It is not a sum. If it was a sum, what would be happening here? Addition, right? The sum means there would be addition, okay? This is multiplication. Therefore, since it's multiplication, since it is a product, I'm allowed to do something that I would not be allowed to do if it was a sum. So if this was 2 plus x squared, I don't get to do what I'm about to do. You have to make sure that you understand they're treated in two completely different ways. Here, this is basically just like two square roots multiplied together. So you can think of it as, like if I have the square root of 2x squared, and we could just do the tree on this. Isn't this just 2 times x squared? Right? 2 is a prime number. What are two things that multiply to give me x squared? X and x, right? So now I have it split up as much as I possibly can. Can I take a pair out? Yes. So the two x's, just one of them gets to come out, and that's 2 has to stay underneath the square root. So basically here, it's like I can take the square root of x squared, it's x. Square root of 2 has to stay the square root of 2. And the reason I get to just apply it to both of them is because it is a product. Okay? If it was a sum, that does not work. Okay? Just same thing with like squaring. All right, so now I get y equals x times the square root of 2. And that is way more profound than you even realize at this point. Okay? So we're just going to pause here for a second. That's what we got with variables. I know y'all feel like, why do we do it with variables? It's so confusing. It's actually easier with variables, and it shows me that this happens no matter what x is. If we do it with numbers, I'm just showing you that it happens with a specific number. But I am going to show you that. So all the way back up here at the top, we're going to do a quick little triangle. 3, 3, we'll call this x. Okay. So what kind of triangle do I have here? A right triangle. Is it an isosceles right triangle? Yes. Okay? Because these two sides are congruent, so it has to be. All right, so I'm just going to do Pythagorean theorem real quickly. So this is 3 squared plus 3 squared equals x squared. 3 squared is 9 plus 9 equals x squared. So x squared equals 18. X is the square root of 18. That's 2 and 9, right? So x just equals 3 squared root of 2. Y'all agree with that? Okay, so. All right. Now, doing that Pythagorean theorem was not that big of a deal. Simplifying that square root's not that big of a deal. But if I change this from 3 to 378, that really changes the game, right? Okay, so don't worry, we're not going to do that one. Actually, we are going to do that one, but look at what's happening here. There's a pattern here. That because I'm using x and y, I'm using variables. X could be anything that would be a positive number that would make sense for a side length, right? So when I do this, since these are the same, every single time, no matter what happens, this 2, I don't get to take the square root of, but I do get to take the square root of this. So this is x, this is x, this is x times the square root of 2. Up here, we just did it with 3. This is 3, this is 3, this is what? 3 times the square root of 2, right? If this was 50, this would be 50, this would be 50 square root of 2. That 378 I just mentioned. 378, 378, and this would be 378 square root of 2. And you didn't have to do the work. Does that make sense? Monkey, monkey, monkey square root of 2. Okay? Doesn't matter what it is. All right? That is your little shortcut for, not only is it a shortcut, but yes, I know, I did Pythagorean theorem here at the top. We did it at the bottom so that I could show you where this is coming from. However, past this, like on this assignment, you are not doing Pythagorean theorem. You do Pythagorean theorem on any of them, I'm going to count it wrong, and I am going to be looking at your work, okay? Because the whole purpose of this is so that you don't go through all of that, and so that you understand how these relationships work, okay? Yes, sir. Now I'll show you exactly what we're going to do here in just a minute. Okay? We all good so far on this? Okay. So now let's go up here and let's fill in this theorem. Now, when you label the triangle and what the theorem actually is, depending on the resources that you look at, sometimes the pattern is shown as x squared root of 2, which is what we used here. I do not suggest that you use that. I think that is a bad idea, because you see how on this one, how x is on the legs? And then you see up here how I put x on the hypotenuse? So if I go over here and label this as x squared of 2, now I have x squared of 2 and x on the same part, and it's just weird, right? So we're going to change the variables, which I have always changed the variable, and it never really matched our textbooks and stuff, but now our new textbook, I guess, had like a hidden camera in my classroom because they changed it to what I think it should be anyway. So your textbook, not that you use it, but it does use what I'm about to do. And every now and then on some resources you'll see it that way. But x is very common to see it that way, and it is a bad idea because it can lead to some big time confusion. So let's first talk about what the pieces of this triangle are. So this side length that's across from the right angle, what is this? This is the hypotenuse. So this is the hypotenuse. And then these other two sides are called what? Legs. Okay, so this is a leg, and this is a leg. Now, because it is an isosceles right triangle, the legs are congruent, right? And everything revolves around the length of the leg. So instead of x, we're going to use L for the leg. And since it is a lowercase l, we make it a lowercase cursive l, even though it's supposed to be printed. That way it doesn't look like a 1 or an I. So this is L. This is L. So what would the hypotenuse be? L squared of 2. If you can label what we just did in purple, you can do every single one of these. If you actually follow the process I tell you to follow, and don't at the very beginning try and do shortcuts and tune me out, because then that will cause you to get some of the other ones very, very wrong. Okay, so the length of AC is L, the length of BC is L, AB is L square root of 2. Okay, so in a 45, 45, 90 triangle, the legs are congruent because it's an isosceles right triangle, and the length of the hypotenuse is the length of a leg times the square root of 2. Every time. Now, the numbers aren't always super pretty, but that's the pattern that works. Okay? We all good? Always going to be like that. For a 45, 45, not every triangle, but for a 45, 45, 90. All right, so let's look at this. Now, once again, it is important that you listen to what I am saying. I know some of these are super easy. Trust me when I say they are not all super easy. Okay, so if you try and avoid what I'm telling you to do at the beginning because you think you can just see the answer, first of all, I'm going to count it wrong because I need to see your labels. And second, the reason I'm making you do that is because they're not all as easy as you think. And sometimes you look at them and you think they are, and it's not what you think, and then you're just totally wrong because you don't really even understand what you're doing yet, and you're already trying to take shortcuts. Okay, so this says find the value of the variable, give your answer in simplest radical form. That means everything always has to be simplified all the way, and no decimals. And always label the triangle. Look at that. It's even in all caps. Okay, so the first thing you have to do is identify your triangle. Is this a 45, 45, 90 triangle? Yes. Okay, so then the next thing you do is you label it. L, L, L squared of 2. This is L, this is L, this is L squared of 2. Then what that has done is that has set up little equations for you. You don't even realize it. This tells you right here that L equals 8 and X equals L squared of 2. And then this doesn't have anything on it, so I don't need it. I need it labeled, but there's no little equation that comes from it. Everybody good so far? Okay, so then you look at your equations. This one has 2 variables. This one has 1 variable. You have to start here. Well, I don't even have to solve anything in this particular problem with this. L is just equal to 8. So I substitute that in there. And what does X equal? 8 squared of 2. Okay? That's it. Because, look, this is L, L, L squared of 2. So isn't this 8, 8, 8 squared of 2? And I realize you could do that one without writing those equations down, but at this point, I don't care. You're writing them down anyway because they do not all work out like that. Okay? Are we good? Any questions? Okay. So let's look at this next one. Is this next one a 45, 45, 90 triangle? Maybe. We don't know is best answer, right? So the worst thing you can do when we start looking at these special right triangles is that you assume that everything is special. Not every triangle is special. You are all special in your own way, each and every one of you, but every triangle is not special, okay? Okay, so here's a right triangle. That means if I was looking for X and Y, and I don't know that it's a special right triangle, right now my only other option, or if it isn't for sure, my only other option is Pythagorean Theorem, and that's not going to get me an exact number, right? So I left that off on purpose so that we could have that conversation. But we are going to do this. You're only getting to do this because I'm telling you to, not because you get to willy-nilly go label whatever you want. Okay, be careful with that. Now, because it is labeled like this, is this 45, 45, 90? Yes, because it's an isosceles right triangle, right? So now that I know that, I can label this as L squared root of 2. And then I set up my little equations. I have that L equals X. I have that L equals 5 square root of 2. And I have that Y equals L squared root of 2. Okay. So this time I got 3 equations because all 3 sides had something labeled on it from the beginning. Okay, we all good so far? So this first one, this is 2 variables. This only has 1 variable. This has 2 variables, so I have to start here. And luckily, again, I don't have to actually solve for anything. I know what L is, so I take this, I substitute it in for L right here. So X equals what? 5 square root of 2, and I'm done. Then I take this, and I substitute it in here, and I get Y equals 5 square root of 2 times the square root of 2. Okay, so I want you to think without speaking. Well, actually, I want you to solve Y without speaking or communicating with your neighbors. What Y is from centos? What would Y be? Like the actual value of Y, what would I get in the end? Okay, so what's the square root of 2 times the square root of 2, Santos? 2, all right? So that would give me Y equals 5 times 2, and then what's 5 times 2? 10. Okay, square root of 2 times the square root of 2 is 2, because the square root of a monkey times the square root of a monkey is a monkey, right? And then you just get 2 times 5. Does everybody understand why there? Thank you, Santos. Does everybody understand why there's 2 square roots there? One of them came from this, and the other one was already there, right? We all good? Any questions? Yeah, Y, well, there's 2. We're looking for X and Y. So X is 5 square root of 2, and Y equals 10. We all good? All right. So let's look at C. Is C a special right triangle? Yes. And so then step 2 is really, okay, well, which one? We only know one right now. So, oh, it's the one I know how to do. And so then I label, right? L squared root of 2. So then I set these up, and I've got L equals Y, 9 equals L squared root of 2, and X equals L. So I have 2 variables, 1 variable, 2 variables. So I'll have to start here. That one's not solved for L, so I got to solve for L. So what do you think I would do to get L by itself? Divide? Everybody agree with that? Yes. Or do I square it? Square it? Why would I square it? Okay, so listen. What my goal is to get L by itself, right? So if I have 3 times Z equals 9, what would I do to get Z by itself? Divide by 3. Why do I divide by 3? Because it's being multiplied. So you do the inverse, right? The inverse of multiplication is division, right? Do you have a question? Okay, I have questions only. So this is, I divide here because it's the opposite of multiplication, right? What's the operation between the L and the square root of 2? Multiplication. You are trying to get L by itself. That's your goal, right? Nobody said to move L, which is good, because people try and move L. You try and do all kinds of weird things because there's a square root there, right? It pushes you out of your comfort zone. But your steps don't change. This right here is multiplication, and you're trying to get rid of this. So you have to divide by whatever's being multiplied. So you got to divide both sides by what? Square root of 2, because you're trying to leave L by itself. So go ahead and do that. Divide both sides by square root of 2. Okay, so how many of you feel like you have no idea how to divide both sides by the square root of 2? All right, so watch this. It's like magic. Bam! Look at that. What? Yeah. Okay, so this is one of those examples of you think that you're stuck, but you're not. Like, so I know quite a few of you, even though most of you pretended to write, some of you were just like pretending to write. But you do know how to divide. That's how you divide by anything, right? Now, you might get stuck somewhere along the way. You're not stuck yet. you're still not stuck. Can you do something else right here? What happens on the right-hand side? They cancel out. That's the whole purpose of why you did it, right? Because you're trying to get L by itself. So now what we have is L equals 9 divided by the square root of 2. Now, do you know what to do with that? No, you don't. I haven't told you yet. That at this point, you're stuck. Okay? And that's okay. I'm going to get you past it. But do you see how you can get there? If you know the steps. You know the opposite of multiplication is division. So, it's being multiplied, I'm going to divide. How do I divide? Oop, it's called showing your work, guys. There you go. Okay? Yes, sir. Well, then you'd have 2 times L, and then you're just doing way too much. So, no, we divide. That's not the way that you isolate the variable is to do the inverse. Okay? Yes. Very good. So at this point, we are not finished. Good job. We are not finished. All right? So the problem here is that our value is correct, but it is illegal to leave a square in the denominator. Except that I told you on Friday we're going to go ahead on that assignment. You're going to leave it, but we just need to know it's not legal because we just weren't ready for that yet, right? So you also need to write yourself a little note here that says never, except for Friday when I said to, never leave a square root in the denominator. Okay? Never leave a square root in the denominator. Except for the assignment that's due tomorrow is okay. I actually I don't want you to go back and have to redo it or anything. So that's why this weird arrow is here, because we don't really have room to finish that here. We're going to go up to the top and we're going to finish this over there. So this value is correct, but we have to change what it looks like. It's just like if I have 4/8. It's not wrong, but I really should have 1/2. Does that make sense to you? So what's illegal here is having an irrational number in the denominator. So an irrational number is a number that cannot be written as a ratio. So it can't be written as a fraction. So if it was pi or if it's a square root or any sort of repeating decimal. So the weird arrow takes you up to the top of the next page, and that's where we're going to take care of this. So if you have a square root or a radical in the denominator, so this, what we're going to put here, it makes you sound real fancy. So if somebody's like, oh, what are you doing? You can tell them what you're doing, like use the real words, and they'll be like, oh, I'll leave you to that. Good for you. Okay? So since what we want is we need the denominator to be rationalized, so we're going to rationalize the denominator. So if you're trying to do your homework and somebody's bothering you, like, what are you doing? I'm rationalizing the denominator. Like, oh, okay, I'll leave you to that, right? Sounds way more complicated than it really is. So here's where we ended. We had L equals 9 divided by the square root of 2. Now, also notice on that problem down there is that once I get L, x equals L and so does y. So once I get L, I don't have to do anything else to it, and then I can get my x and y pretty easily. Now, what I need is for the square root to not be in the denominator, but I also have to not change the value of this, just like 4/8 and 1/2 is the same thing. So what can I multiply anything by that doesn't change the value? 1. So I have to multiply it by some form of 1, which is just going to mean a fraction where the numerator and the denominator is the same, right? What can I multiply the square root of 2 by so that it's not a square root anymore? Square root of 2, right? So if I'm going to multiply the denominator by the square root of 2, this I have to multiply by square root of 2, okay? So then I multiply straight across. What's 9 times the square root of 2? 9 times the square root of 2. Over, what's the square root of 2 times the square root of 2? 2, okay? Now, I reduce if I can. Can I cancel these 2's out? No, because they live in 2 different worlds, right? There's a square root world and the whole number world, and we don't mix. Here, I do not divide and get a 4.5, okay? If this was 8, I could divide it and get 4 times the square root of 2, okay? But it's an odd number, so I cannot reduce this anymore. This is L, okay? So since that's L, and I had over there that x equals L and y equals L, then x equals 9 square root of 2 over 2. and y equals 9 square root of 2 over 2. Okay, and so this is my actual x and y values there. Now, those look kind of ugly. That's really not anything compared to some of the stuff we're going to get, so you have to kind of get used to that it's not always going to be real pretty answers in the end, but those are your exact answers there. Okay, we good? Now, Michael said on the other one, well, couldn't we multiply both sides by the square root of 2 and then I'd have to divide by 2? You would end up getting the same value, but that is not how you isolate a variable, and you're doing your whole lot more work, which will make things a whole lot uglier sometimes when the numbers aren't simple like this. Does that make sense? It's like it would get you there, but it's going to complicate things in some situations. Okay, but it wasn't illegal like some of the other things people were saying. All right, anything else? Are we good on this so far? Okay, so let's look at the next one. I'll have you work through one a little bit on your own. This says Shannon is cutting a square of material for a tablecloth. The table's diagonal is 36 inches. She wants the diagonal of the tablecloth to be an extra 10 inches, so it will hang over the edges of the table. What size square should Shannon cut to make the tablecloth? All right, so we know it's a square, so these are right angles, and all 4 sides are congruent. What is the length of the diagonal of this tablecloth? Try again. 46. Okay, this is not the table, this is the tablecloth, so it is 46 inches. And so this, what size square, I'm really just looking for the side length. I should probably reword that because it sounds confusing, but it's just the side length. So do you have a triangle here that you can use? Yes, 45, 45, 90? There's 2 of them. You only have to find one of them because they're the same, right? So I'm going to give you a minute. I want you to label it, your L squared root of 2, set up your little equations, work through it. I'll give you time to do that while I pass out the homework. Okay, so I've got L squared root of 2, right? So we've got that L equals X. That actually happens twice. You really only have to write it once. And then L squared root of 2 equals 46. So here I have 2 variables. Here I have 1. So everything revolves around L. What do I do here to get L by itself? Good. I divide both sides by the square root of 2. Okay, these cancel out. So that leaves me with L equals 46 divided by the square root of 2. Then little bells and whistles should be going off, little red flags. Danger, danger, don't stop here, right? So I have to do what? What are the words? Rationalize the denominator. Okay, which means I'm going to multiply it by, now in this case, you're going to end up with square root of 2 in the denominator every time because of the pattern that we're using. But if this was the square root of 5, then my fraction would be the square root of 5 over the square root of 5, right? That's how you decide. It's really not that hard. So square root of 2 over square root of 2. I multiply straight across, and that's going to give me 46 square root of 2 over what? 2. Can I simplify this? Yes. I do not just knock the 2's out, because that's a big time no-no. But I do get that L equals what? Oh, let's try again. 23 square root of 2. Okay, because I can, since this is even, I can reduce that right there. So that's my L, which is the same as X, right? And so to answer the question that isn't worded that great to begin with, what size square? So really, when you talk about what size a square is, it's by its side length. So we can just say that the side length then of the tablecloth equals 23 square root of 2 what? Inches. Inches squared? Just inches, right? Everybody okay with that? So here's an example of where we'll actually reduce, and then if it's an odd number, it has to stay as a weird looking fraction. Okay? We good? All right, so look at your homework real quick. The directions up at the top. I put it in bold. I even put not in all caps. Okay? Do not use Pythagorean Theorem on any of these. Okay? No. All right? You want to use the shortcut, trust me. Okay, but label all of them, L squared 2. You will get to a point where you're not having to label it every single time, okay? Some of you will get quicker than others, but we're going to use this for the rest of the year. It's going to come up in everything that we do. And the idea is that you get good at it where you can just recognize it and not have to go through all that every time, okay? But right now, you need to go through it every time. Otherwise, what I've noticed is that then you assume things are happening when they're not, and you need a better understanding of it.